Welcome back. The objectives of this video is to explore inverse functions. We will look at properties of inverse functions, we will go ahead and graph inverse functions, and we will define inverse functions. First, we'll take a look at a relation. A relation is a set of ordered pairs, and a function is a relation in which for each distinct x value there is exactly one corresponding y value, meaning in a function we can't have one input go to two different outputs. If a function f is a set of ordered pairs x, y, then the inverse of the function is the ordered pairs yx. So you'll see a lot of flipping of our ordered pairs as we study inverse functions. When the inverse of a function f is itself a function, then f is said to be a one-to-one function. And a function is said to be one-to-one if the elements a and b in the domain of f, a can't equal b, implies f of a then does not equal f of b. That is, different values of the domain correspond to different values of the range. In example 1, we're going to justify each mapping with an observation. So in 1 here, the domain and the range, we have 1 goes to 4, 2 goes to 5, 3 goes to 6. That is a one-to-one function. Each x has, in the domain, has only one unique y value. In the middle diagram here, we see that 1 goes to 4 and 2 goes to 4. This is not a one-to-one function. This is actually a two-to-one function. So this is 2 to 1 because we have things, two inputs are mapping to the same output. Now that is a function, but it's just not one-to-one. So this would fail the horizontal line test. We haven't seen that yet, but we will take a look at that as well. So that would be like a parabola fails the horizontal line test because our horizontal line passes through our parabola at two different locations. So a parabola, while a function, is not one-to-one. And finally, in our third one here on the right, this is not a function because 1 maps both to 4 and 5. We've got the same input going to two different output. This actually fails the vertical line test, so it's not a function. Now, I don't know if we can say that on the AP test, that it fails the vertical line test. You'd have to talk about that one maps to two different, the same input maps to two different outputs. So here's your information on the horizontal line test. If the graph is known, you can use the horizontal line test to determine whether it's one-to-one. And if every horizontal line intersects the graph at most one point, then it's one-to-one. Let's take a look at some properties of inverse functions. Graphs of inverse functions are reflections in the line y equals x. We have not seen that, but we will go ahead and graph y equals x. Really a slope of a line that goes through the origin that has a slope of 1, and we will reflect over that line. Given a function f of x, the notation for the inverse function, we will notate an inverse function using f of -1 of x. So that's not a reciprocal of the function. That means inverse of the function. So f -1, or the inverse of the function of x. The domain of the function is equal to the range of the inverse function. Remember, we flip our x's and y's. And the range of a function is equal to the domain of the inverse function. In example 2, for each of the graphs below, we're going to draw the line y equals x. Then we'll sketch the inverse of the function on the same grid and check to see if the function is one-to-one. So I've taken a moment for our original function to map some ordered pairs. So our ordered pairs, we have -3, -2, -2, 1. We have 1, 0, and 6, 1 on our original function. I've also put in the line y equals x. And Now we can map our inverse function, which would be -2, -3, which would be -1, -2, which would be 0, 1, and 1, 6. So our inverse function is going to look something like the blue graph there, and it is 1 to 1, and it passes the horizontal line test. In example B, did the same thing. We've got a parabola here. Now this fails the horizontal line test. A parabola is not a one-to-one function. I've drawn the line y equals x, and we want to sketch the inverse of this. So I've grabbed some ordered pairs from our original parabola at -3, 7, at -2, 2, at 0, -2, and we'll find and sketch the opposite. So we have 7, -3, 2, -2, -2, 0, -1, 1, 2, 2. So we have a common point, and 7, 3. So we flipped all our x's, y's, and then we'll plot those. So I've plotted all those ordered pairs, and you can see here we have a same kind of diagram. We still have a parabola that opens sideways. This fails the horizontal line test. This is not one-to-one, so the inverse does not exist. So fails horizontal line test. It's not one-to-one, so the inverse function of x does not exist. And going back to A, just finishing up our notes there. Here, f of x is one-to-one, and the inverse of that function does exist. Here's the definition of an inverse function. Let f and g be two functions such that f of g of x equals x for every x in the domain of g, and g of f of x equals x for every x in the domain of f. This is actually an exercise we did in a previous video. So the function of g is the inverse of the function of f, denoted f inverse of x. Therefore, f of the inverse of x equals x, and f the inverse of x equals x. The domain of f is equal to the range of the inverse, and vice versa. So show that these functions are inverses of each other. So what we're going to do is we'll find f of g of x, meaning we'll put g of x into f. So we have 4 times x minus 3 over 4 plus 3. We've taken x minus 3 over 4 and put it into f, and we simplify that. Looks like the 4's cancel here, and we get x minus 3 plus 3, and we get x. So f of g of x is equal to x. Then we'll repeat the process with g of f of x. So now we'll take f of x and we'll put it into x for g. So that becomes 4x plus 3 minus 3, our old x, minus 3 all over 4. And that becomes 4x plus 3 minus 3 cancel out, becomes 0. We get 4x over 4. The 4's cancel, and we get x. So we can say that f of g of x is equal to g of f of x, and both of those equal x, though therefore those are inverse functions of each other. So that wraps up our introduction to inverse functions and definitions and doing some graphing, and we'll get some more practice with this when I see you in class.